Hey folks, welcome back. In this class, we are going to do the last part of our motion time graphs, and that's in converting between them. So for our first lesson on this, we're going to be converting a displacement time graph, which is a graph that shows how far something has gone over time. Okay, it's gone 10 meters in 3 seconds. And we will turn that into a velocity time graph. And this just will rely on a bit of our understanding that we've worked on for the last few lessons, but let's see how we go. All right, so what we've got here, displacement time graph. I know it's a displacement time graph because it's displacement on the y-axis, it's in meters. Time, it's in seconds. We're looking pretty tight. What we need to do is we need to find out what are the values, the velocity of each of these different sections on this displacement time graph. And you could always start just for 10 seconds, might be helpful. It looks like this is moving away in a positive, then it's not doing anything, then it's starting to come towards the origin, then it's away from the origin in a negative, and then it's not doing anything. So you can always spend that first 10 seconds getting a bit of a picture, that sort of thing. All right, so how do we calculate velocity? Well, just to remind you what we looked at, it was a few lessons ago, our velocity equals displacement over time. Okay, and if it rejigs your memory from year 9, that would be gradient, which is rise over run. Okay, so we need to find out the rise over run, the gradient of each of these sections. So this first one here, what we have is 5 displacement over 3, which is our time. Now I've chosen that's 1.6. That's a bad fraction, I think. Normally these things would be like 10 over 2 or something like that. They're not going to be too tricky, but you can always use your calculator for that sort of thing. Now this gradient, easy. It's 5 over 0. Not 5 over 0, sorry. It's 0 over 3 seconds, which is going to be 0. It's flat. So we know, and if I was to put the units of measurement here, it's 0 meters per second. There's no change in displacement over time, which means that the object is not moving. Okay. Now this section here, between the 6 and the 7, that's going towards the origin, and it's in a negative direction. So we know it's going to be negative. I'm just going to put that there just to remind myself. Now our rise is 5. The reason it's negative is actually because it starts off 5 to 0, so it's negative 5, and that's over 1. So it's going to be negative 5 meters per second. All right, now this next section here, we have a rise of negative 6 over a run of 7, 8, 9, 2 seconds here. So negative 6 over 2 equals negative 3 meters per second. So far, so good. Our last section, it's negative 6 here. It ends up at negative 6. If this was a perfectly straight line, it's not the best graph, but that's what's happening. There is no change in its displacement even after just a few seconds here, right? So in this case, that's going to be 0 meters per second. Now, you can't skip this step. You have to go through it. No matter how confident you are in doing in your head, you have to break it down into sections because, we can't get any really more complicated than a few of these parts, but by and large, there's just a lot of information. There might be 6 or 7 different segments, okay? So that's our first step that we do. The second step is we've got to start drawing. So what we do is we need to get our axes sorted first. So I don't know if it's negative or positive just yet. Oh, actually I do because I've got some negative values, so we know that's going to happen. But we're just going to draw a line. Now, time is the first part I like to focus on because it's the easiest. Time is going to be exactly the same for the velocity graph as the displacement graph. So we're just going to put our main ones that we want to look into. 3, that looks about a 6. So it's a rough 6, 7, 9, 12. Okay, and we're going to need our velocity. in meters per second. And I know there's going to be a zero. Oh, so I'm going to rewind that because my writing should be a little bit better. Velocity in meters per second. Okay, so we've got our origin. All right, so to label our velocity, we really need to know what's our max and what's our lowest. So just eyeballing it, we've got 1.6 meters over here. That looks like the highest positive value that we have. And negative values, -5, -3. Okay, so -5 is going to be, it looks like our biggest number, right? -5, and just reflecting that on the top, that will be 5. And then we're just going to break these into discrete little chunks. Keep it nice and even. 3, 4. 1, 2, 3, 4 like that. -1, -2, -3, -4. Cool. So we've got our axes. Now just to rewind just a little bit, if you have done, this would normally be a 3 or 4 mark question. If you do this part, that's a mark. Okay. So it's very important that you get that done. Just a bit of a reminder. Okay. So now we need to have a look at what's going on. We need to start graphing. Our displacement starts at 0. Our velocity in this case, it doesn't actually start at 0 though. It doesn't start at the origin. Our first velocity is 1.6 meters for 3 seconds. So 1.6, it's about halfway there, okay? And for 3 seconds. So what I like to do is just get my 2 points in first. Eye it up. It looks like it's 3 seconds, 3 seconds. Okay, cool. 1.6, 1.6. Excellent. So we're just going to draw a straight line like that. Cool. Then it goes to 0 meters per second for another 3 seconds. So that's going to be over here. We have a blot here and another point here, and we're going to fill it in. And what we do is we have to connect it up. Now I talked about this a lesson beforehand. This is unrealistic. You can't be going at 1.6 meters per second and then instantly just go straight to 0. There has to be, like, a realistic one would be like, okay, it would start to decrease like over time. But for our purposes, we have to just sort of keep it a bit simple. So you have to suspend a bit of reality in that sense. All right, now we jump to -5 for 1 second. So that's going to be, I'll just move my head out of here. This is getting in the way of important information. So we'll go to -5. We'll go straight down. Straight down, sort of. And we go like that. Cool. And then -5 for this section, then -3 from 7 to 9. Okay, so about here. That matches up to -3. And for another 2 seconds, we will maintain that velocity because that's what it is. And then we go straight to 0 to finish it off. All right, there's a lot to unpack there, right? But those are the key details. First thing is, whatever graph you've got, figure it out. See what the journey's going on, and then break all the different chunks in. Especially for something like this line here, because you might be like, oh, it's the same, but it's not. In this case, it was -5, and then it started to slow down to -3, which is, does that make sense? I hope, like, -3 is slower than -5. Remember, the negative just means a direction. So do that, unpack it, get your calculations, then get your axes sorted for your velocity time graph. Spend like a minute, like just get it really solid. The time is easy, get your main points in. I mean, I probably cheated a little bit. It probably would have helped to have the main, like maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 all in. But honestly, I'm not too stressed about that. And then we put the plots in. The last thing that you can do, which I would highly recommend that you do, say if this is an exam or a test, if you have the time, is you backtrack. So and you might not have time to do all of them, but you could look at something like this and you say, okay, this is 1.6 velocity times 3 seconds. It's 1.6 recurring. What is that? 1.6 times 3. Okay, that's 5. Okay, 5? 5. That makes sense. Cool. What's 0 over 3? Or 0 times 3? It's 0 as well. So you can do it for all these sections. That's a really good strategy just to do at the end. Make sure you're on the track. All right, other than that, peace out.